får jag säga hej och välkomna till webbinariet EZtol. Och jag börjar med att köra en liten kort presentation om oss på Ariadne här, vilka vi är. Vi är ett ingenjörsföretag som hjälper med digitala simuleringar och beräkningar. Och vi vill ju hjälpa er att jobba effektivare och öka konkurrenskraften och öka lönsamheten. Och just det här med toleransanalys så kan man spara mycket pengar. Så vi tittar på bilden nere till höger så ser man våra kompetensområden. Vi utgår från mitten där med digitala CAD-modellen och precis nedanför så står det MBD, Model Based Definition, och det är någonting vi jobbar hårt med just nu faktiskt. Vi vill hjälpa företag och jobba effektivare som sagt. Vi kommer se lite fördelar med MBD idag, för har man toleranserna i 3D-modellen så läser ju programmet in dem helt automatiskt och man slipper all manuell inblandning. Så det går ju bra mycket snabbare och man minimerar ju riskerna för fel. Våra affärsområden, det är ju mjukvara, konsultuppdrag och utbildning. Vi är PTC-återförsäljare med Creo och alla program runt omkring där. Sigmetrix som har verktyg för toleransanalys. EZtol som vi ska titta på idag är ett av dem. Capvidia som har Model Based Definition och automatisk kvalitetskontroll. Anarch som är Model Based Definition och intelligent informationshantering. Konsultuppdrag, vi gör ju då Model Based Definition workshops och vi gör toleransanalys och hållfasthetsberäkningar, form- och lägescoachning och mycket mer. Så det är bara att höra av er om det är någonting ni behöver hjälp med. Utbildning. Vi har ju gjort en hel del kurser själva faktiskt som vi är väldigt stolta över, så att de här kurserna har vi utvecklat själva och det är ju då grunderna i toleransanalys och det är form och läge, det är FEM för konstruktörer och design för 3D-print. Men om vi då ska prata lite toleransanalys, vad är toleransanalys? Konstruktörerna sitter ju i en perfekt värld och så ser det inte ut efter tillverkning när man får detaljen i handen. Det finns ju alltid en variation. Det blir alltid lite större eller lite mindre. Och sen när man monterar ihop allt det här så blir det då en kedja av toleranser. Det kan bli ganska stora variationer i slutändan. Då gör man ju en analys på de här toleranserna så man får fram vilka dimensioner som påverkar mer eller mindre och så kan man då optimera toleranserna. Varför ska man göra en toleransanalys? Ja, det är ju att få svar på hur och vart man kan spara tid och pengar. För det blir ju då färre prototyper och det gäller ju att vara snabbare än sina konkurrenter, snabbare ut på marknaden. Och det blir ju då ökad kvalitet och minskad support och nöjdare kunder helt enkelt. Sen har vi den här klassiska kampen mellan konstruktörer och tillverkning. Så det är ju då vilka toleranser krävs. Det är ju då att konstruktörerna han vill ha snäva toleranser för att säkerställa funktion. Oftast tar man i lite för mycket faktiskt. Och tillverkning, de vill ju släppa på toleranserna för att sänka produktionskostnaden och så. Så att det blir ju då en balansvåg och just då med en analys så kan man ju då få en bra fördelning på det här som man har koll på läget. Då ska vi se. Då tror jag det är dags för ett demo för att se hur det här fungerar. Felix.
All right, thank you, Patrick. I'll just share my screen. Okay, welcome everyone to this practical demonstration of EZtol for Catia and NX. My name is Felix and I'm an application engineer here at Ariadne Engineering, mostly involved with tolerance analysis. And as I said, I'm going to give a short demonstration right now, and afterwards we're going to answer your questions. So EZtol analysis for Catia and NX is a standalone application where you load in your CAD model. So in this case, I'm going to open a Catia product, but it could also be an NX assembly file, for example. I'll just confirm that I want millimeter as my units. And then we have the interface right here. So we have the graphical interface in the middle, left-hand side, we have the model tree with all the parts of the assembly. And then on the right-hand side, we're going to have our stack-ups. And the great thing with EZtol is that you are working directly with the 3D geometry. So that helps immensely with the visualization compared to normal spreadsheets. And also we can reuse all the PMI we have in the 3D model. For example, if I activate the annotations here, we can see we have a lot of 3D annotations, which I'm going to reuse for my tolerance analysis. But let's get started, and I'll show you how easy it is to create a one-dimensional stack-up. So in this case, I'm going to hide the axle and the wheel, because what we're going to want to investigate first is the alignment of the two bushings so that we can fit in our axle in between. And for that, I'll just create a new stack-up, select the features I want to analyze, so the two holes in the bushings, and then place my annotation in the environment. All right, next step is to select all the parts in the tolerance loop. You can see one bushing is already transparent, so which part is the next? That would be the axle support, the top plate, axle support on the other side, and the last bushing. And the last step is to select the contacting interfaces. So how do parts interact with each other? So in this case, we have outer diameter of the bushing to the hole in the axle support, two surfaces here, two surfaces here, and then the same on the other side. And you can see it's really easy and intuitive. A lot of development has gone into making the interface as accessible as possible. So like that, I'll just click OK, and I've created my stack-up. Last thing to do is, what's the name of the stack-up? I'll just call it axle alignment. And what's my requirement? In this case, I want to have the two holes within plus minus 0.3 millimeters of each other. All right, so you can see all the nominal dimension in the graphical interface. The red one is, of course, what we're investigating right here. And of course, in the perfect CAD geometry, the two holes are perfectly aligned with each other. And then down here we have, well, at the moment, our worst case result. So we can see here, nominal in the middle. Then I have my requirement plus minus 0.3. And with my current tolerances, I can have a deviation up to plus minus 0.75 in a worst case scenario. So how do we get this result? Well, we get it through all the tolerances shown in the table above here. And you can see here, if I hover over one of the parts, it will highlight in the graphics environment. So first the bushing on the left-hand side, and then we have the hole, which has a diameter of nominally 12.05, and then a certain tolerance. And on the right-hand side, we have this chain link icon, which means that this tolerance is an imported one. That comes directly from our 3D model. Then we have the outer diameter, and between them we have a runout tolerance. So we support both like size dimensions, linear dimensions, as well as geometric tolerances. And you can see for now I've imported all my tolerances from the 3D model. And with that, it's just a few clicks and I've set up my analysis. That's really quick and easy. But of course, the advantage of EZtol is that you don't only get the worst case result, but also a statistical analysis. So you can see up here, I can change between different analysis types. The current one, that's worst case, but I can also show root sum squared or a certain statistical metric. For example, capability, sigma value, percentage of yield, or defects per million opportunities. Let's have a look at capability, or CPK, which is a very common industrial metric. And capability basically describes how well you fulfill your requirements. So you can see here the results window has changed a little bit. We get a lot of more information right now. For example, we have a target quality which we want to reach. In this case, it's set to 1.33. We have a current quality, which is 0.8. We have a mean and a standard deviation. And of course, we have our statistical distribution right here. How do we get that distribution? Well, when we switch to statistical analysis, we got another column called CP, or capability. And that basically says that each part and dimension is manufactured to a certain quality. The default one you can see here is 1.0, which is a little bit more conservative estimate. But I can change that if I want right here. So for example, if I say, hey, this part is from a supplier which is a little better, then I just increase the quality maybe to 1.33, and that will be taken into account in my analysis. So really you have a lot of customization options for your statistical analysis. All right, so we have a target quality. I want to reach 1.33, which is one that is common, for example, in the automotive industry. In other industries like medical or defense, you might have a higher target quality of 1.67, but it really depends on your specification and the product. For this, 1.33 is good enough. However, currently you can see I'm only reaching a quality of 0.8, which is not that great. So now we want to increase, well, our product so that we reach the desired quality. And in this case, we do this by tightening some of the tolerances. But, well, we have quite a few in the chain here, so which one should we tighten? Well, we can take a look at the contribution tab right here, which lists all the tolerances in the chain. And we can see here the top two, together they're nearly 90% of the contribution. So they are optimal candidates for tightening tightening tolerances and increasing quality. So there are surface profile tolerances right here. Currently 0.5. So I'll reduce them to 0.2 and see how that affects my result. Well, you can see currently I'm not able to. In this case, I want to break the link first. So now I'm not using the imported tolerances anymore, but I can choose my own. So I'm going to 0.2 here, just like that. And now looking back at the result, you can see I've eclipsed my desired quality, and now we are at 1.58, which is great. So in this case, I might be able to loosen some of the tolerances to make manufacturing cheaper until I reach my desired quality again. So in this case, I want to loosen some of the low contributors. In this case, run out 0.1 right here. I'll put that to 0.2. Need to break the connection again first. 0.2. You can see now I'm pretty much at my target quality of 1.33. So this is an excellent tool to have a look at your stack up and decide where you might need to tighten or loosen some of the tolerances. Additionally, you might have noticed the message down here. It says calculated results are ignoring potentially significant 3D effects. And this is a hint that your current analysis might not be fully one-dimensional. So there can be some two-dimensional or three-dimensional effects which you might want to investigate. And again, this is not something a spreadsheet would give you, but since we are working with the actual geometry, we can investigate and see if a certain analysis might be not fully one-dimensional. All right, when I'm finished with my analysis, I can go back to the overview right here. And of course, often you have for any given product, not only one specification, but multiple. So I'll add another stack up. And in this case, I want to investigate the distance between the wheel and the top plate right here. All right, and again, which parts are part of my tolerance loop? The axle, bushing, axis support, top plate. Again, where do they contact? Right here. So you can see it's very intuitive and easy to create your stack up. Then just click OK. And again, all the nominal dimensions will appear within the graphics interface. You can see currently I'm going from top surface to the center axis. I want to fix that. So just go to the stack up and choose an attachment, in this case near. All right, now we are measuring from the top of the wheel to the bottom surface. And I'll just call it wheel clearance. And a requirement, well, I want that to be above 13.5 millimeters right here. And again, just like that, we've created our analysis. Of course, you might not have 3D annotations in your product. If that's the case, you can very easily add tolerances within EZtol directly. So we support adding linear dimensions, size tolerances, geometric dimensions on the fly, and that's really no problem. So then I would just go in here for the wheel. What kind of size dimension do I want? Should be symmetric, should be plus minus, limits as I want. For example, here I can have a linear dimension going from the outer diameter to the inner diameter, but I can also have a geometric tolerance. And in this case, what is appropriate? Position, runout, and coaxiality. So even without 3D tolerances, it's really easy and quick to create your analysis. All right, after I'm done with all the specifications, I might want to share my findings with colleagues. And for that, I can automatically generate a report. And for that report, I can create snapshots of each individual analysis. So I'll just rearrange this right here a little bit. Go like here. And then I can take a screenshot up here. I'll do it for the other one as well. Just move them a little closer. Right here, take another screenshot and one for the overall product. Then just click Generate Report, give it a name. And what happens then is we create a HTML document, which you can easily share. You can see it has my kind of title, snapshot, date, of course, summary of my requirements. And then for each requirement, we have a screenshot, list of the involved tolerances, result picture, and then a list of the contributors. Then, of course, for all the others as well. So that's, again, very quick and easy way to publish this information. All right, one last thing. You might wonder, well, what happens to all this information? Where does it get saved? What happens if I do some changes to my model? Again, it's really convenient. If I do some changes to my geometry, let's say I make the wheel bigger, smaller, what I do then is I just reload the CAD model, and then all the information in my stackup gets updated automatically. So if the nominals changed, they'll get updated automatically. If tolerance is changed, they'll get updated automatically as well. So again, you don't need to go back and play with your spreadsheet again. It happens automatically. And after I've done my work, I can save this information as a separate file, wherever you want. And then if I want to get back the next day, I just load in the model, and then I just load in, open the file. So for example, here I have a file where I have multiple specifications. So I can just open that one, and you can see it will automatically attach itself to the model. You can see here I have a few more specifications defined. So this is a very easy and graphical way to do your one-dimensional stack.